Educational Center. I'm Mr. Moko, one of the science tutors at Finn Educational Center. Today I want us to look at one interesting topic, concentration. Concentration. This is a topic that leads into the standards authority. I'm sure every country has a standards authority where they look at or they assess the products that are sent or produced by industries. So I want you to pay attention and then get it right. As usual, our world, which is we are learning to know mole concentration and then mass concentration. So what I'm going to do is I'm going to start with concentration. We are going to define concentration. It's simple. If I give you a glass and then I put salt inside a glass and then I decide to pour water, I there form a salt solution. Now the moment you get this solution, you can think about or you can calculate the concentration. So what you mean by concentration is simply mole per volume. It's as simple as that. The number of moles of the salt that you put in the solution per the volume of water. So we normally use C to represent concentration. So as I develop the formula, I get C is equal to small n. In our previous lesson, we said that small n stands for mole or number of moles. Then per volume. Per volume. Now we need to note, we cannot learn in isolation. We need to note that the unit for mole is MOL. And then the unit for volume is dm cube. Is dm cube. So the unit for concentration is mole per dm cube. It's mole per dm cube. So this is quite easy and then on point. So can we try one and see? You go to buy drink from the market and then you have this 6 moles of almighty sodium chloride was dissolved in 200 centimeter cube of water. You need to take your calculators because here we'll do some calculation. So if you are asked to find the concentration, let's see what we'll do. I keep on telling you that in science there are a lot of formulas. One of the assured way for you to keep the formulas is to write them anytime you are solving a question. So solution. I've been asked to look for the concentration, so I put my formula down. Concentration is number of moles per volume. Now I need to go into the question and look at the quantities that have been given. Of course, the number of moles is 6. And then the volume is quoted as 200 centimeter cube. Be mindful, when I started, I said that the unit for concentration is mole per dm cube. Note it. So here the volume is centimeter cube. What you need to do is to convert. So converting 200 centimeter cube to dm cube, all you need to do is to divide by 1000. So this implies 200 divided by 1000, which is 0.2 dm cube. Once you get this, then it means you're on the right path. Now we can, once we've gotten the volume in the dm cube, be mindful the volume must be in the dm cube, not cm cube. Then we can come and then say that concentration is equal to, instead of n, number of moles, we put our 6 there, pick your calculators, and then the volume, we will not quote this in dm cube, so 0.2, so 6 mole, 0.2 dm cube, and then finally this will give us 30 mole per dm cube. I think that's the correct answer. Good. Yes. Now, what I want you to understand is, you saw that here we were quoting in moles. We were quoting in moles. So we were quoting in moles. So we said mole concentration. In other books, you see that you'll be asked to find the molarity. Molarity. Please be mindful about that. Molarity is the same as mole concentration. And then we'll look at mass concentration. Mass concentration. Mass concentration, we use rho. It's a Greek symbol, rho. Which means we have the beaker, we put salt there, and then we fill it with water. We still want to find the concentration of this solution. But in this instance, what we want to do is, we want to find the mass of the salt per the volume of water. So that is what leads to mass concentration. So be mindful about molarity, which is mole concentration, and then mass concentration, which we can say molality. So the difference is R and then L. Good. So we can say that the unit for mass concentration is grams per dm cube. We can take one example and then calculate. Find the molality in 9.2 grams of (250 centimeter cube) potassium chloride solution. Good. So molality, which means we are finding the mass concentration. Here too, you need to pick your calculators. It's allowed. So solution, mass concentration, molality. So what you need to do is mass over volume. When we look at the question, mass has been given as 9.2 grams. Volume was also quoted as 250 centimeter cube. But be mindful, centimeter cube, no, dm cube. So we need to convert. So 250 centimeter cube to dm cube. We said that just divide. So divide 250 by 1000, which will give us 0.25 dm cube. Then we can come back to our molality, which is mass concentration is equal to 9.2 divided by 0.2. I'm sure you have taken your calculators. 9.2 grams divided by 0.2 dm cube, and that will be 36.8 grams per dm cube. So that is it for mole and then mass concentration. There's one thing that I just want to add. I just want to add it. We know that concentration is equal to N over V. And in our previous lesson, we said that N is equal to small m over big M, mass over molar mass. Now, we want to recreate. So we are going to rewrite this formula, and where we see N, we'll replace it with small m over big M. So small m over big M. This pair is the same as divided by volume. So I have rewritten this formula in this way. Now, as we move on, small m over big M, what I'm going to do is I'm going to multiply. I'm changing the division sign to multiplication sign. And anytime you do that, there is a rule in mathematics that says that you should find the reciprocal. So V is the same as V over 1. 2 is the same as 2 over 1. So the reciprocal of V, which is the same as V over 1, is 1 over V. So 1 over V. When I do that, you realize that this formula changes to small m times 1, which is small m, big M molar mass times V, which is mV. Don't forget this formula. It's also very important. Don't forget this formula. It's also very important. But I see something here that I want us to look at. I see a relationship between molarity and then molality. That's mole concentration and mass concentration. Because I've realized that, yes, I can maintain this C, but mass over volume represents molality, mass concentration, and then I bring my molar mass. That's another formula that we can develop and use in calculation. Okay, once again, thank you.